In this video, we are going to see about applications of finite automata. So application of finite automata. So the finite automata includes both the deterministic and non-deterministic finite automata. So these are essential in the theoretical computer science, and they have a wide range of practical applications. And same time they are used to model and solve the problem that involved in the pattern recognition, then state transition and the control flow. So the first application is test processing and pattern matching. So here we are widely using in the searching for pattern within a text, then foundation task in the computer science. And regular expression can be translated into finite automata. So it will allow the fast and efficient pattern matching, especially when we are using the large text file. And the best example for this one is Unix tools. Unix tools. So like grep, then set, awake, then lex. So these are the finite automata to process and match the pattern defined using the regular expression. And the searching algorithm, that is a KMP algorithm, so uses the state machine efficiently for the for finding the substring. The next one is the lexical analysis and the compiler. During the compilation of the source code, the compiler needs to break the code into the token. So how it will break the code into the token means by using the keyword, variables, symbols, numerics. Like that way it will break the code. So the structure of the programming language token can be described using the regular expression, and this can be converted into the DFA for the efficient scanning of the input. So the example for this one is lexical analyzer, that is the lexiger. It is usually implemented using the DFA. And a lex tools like a lex, it generates the DFA from the regular expression describing the lexical pattern. And next one, network protocol and the communication. So the network protocol involves in the sequence of message exchanging. So it can be modeled as the transition between the states. And finite automata can model how the system should be responded to the input, like when you are giving the packets, acknowledgements or errors, ensuring the reliability and the correctness. Then example for this one is protocols like TCP, then HTTP, then FTP. So they have a well-defined state machine. Then automata are used to verify that protocol implementation adhere to their specifications. Next one is a digital circuit design. So here sequential logic circuit like flip-flop, then counters, control unit, so are modeled by using this state machine. So the circuit transition between the discrete state, it is based on the input signal which is naturally modeled by the finite automata. So for this only we are using it is based on the Moore and Merlin machines, a type of the FA used to design the control logic for processor, elevators, and vending machines, etc. The next one is the natural language processing. So it can be model, syntactic, and morphological aspects of the natural language. So this language, especially at the morphological level, often exhibit regular pattern which finite automata can efficiently capture. So here the best example for this one is spell checking, speech recognition. Spell checking means detecting the valid or invalid word sequence. Then speech recognition. So model the phonemic transition using the weighted automata, and same time the breaking the words into the stems and affixes. The next one, model checking and verification. So model checking involves verifying that the system behavior satisfies the certain property. So it enables the automatic verification of system properties like safety, then liveness, correctness by exploring all the possible transitions. The example for this one is systems are modeled as the automata, and temporary logic specifications are converted into the automata and checking it against the system behavior. Then artificial intelligence. It is a rule-based system or a game agent can operate based on the finite set of rules and the state transition. So this finite automata provides a predictable and testable framework for designing the behavior system in a constrained environment. For example, game AI uses the FA modeling enemy behavior pattern. Then next one, the important thing is the robotics. The FSM, that is the finite state machine, helps in the task execution, planning, and the behavior control. The next one, regular expression matching in a database. So here by using the pattern matching like similar to, based on that it will allow the query involve the pattern matching, and regular expression can be compiled into the automata to allow the efficient evaluation of pattern based condition. So for this one is SQL queries. We can give the query for this, and search engines. So by using search engine, we can able to match and filter the input using the regular expression. The next one, control system and the robotics. So this control system often need the transition through the series of predefined states based on the sensor input and the user commands. And for example, for this one is industrial robots follow the sequence like move, grip, lift, place. So each model does a state. Then a traffic light controller, automatic door, home automation system. So it will be work based on the control system and the robotics. Then last one, bio informatics. So the biological sequence like DNA, RNA, protein, it also analyzed using the pattern matching here. And this pattern exhibit regularity and can be modeled as a regular language. Then example for this one is modifying the detection, that is finding a repeater specific pattern in a DNA. And next one is a sequence alignment. So it is automators are used in a efficient matching and the scoring. Yeah.